All right, what we're going to do now is we're going to take a look at the general form, which we'll call it, for the disk method. So you can grab some colored pencils on this one. This might help the colored pencil realm. It disappeared.
Oh, this is, did it actually fall down?
All right, so let's go ahead and do this problem. Consider the area bounded by h of x equals the sine of x, g of x equals 2, x equals 0, and x equals 2 pi. And we're supposed to find the volume of that solid that is after it's generated by revolving the area about the line y equals 2. Okay, so let's draw the picture. In these problems, drawing the picture is the first step. And in these problems that we're going to do this week, you got to kind of do a little prediction prior to this. For example, in this problem, we're going to be revolving it up, okay, rather than down. So you're going to need more space above than below. So this is the line g of x equals 2. We're going to revolve this about that line. So this is my axis of revolution. And then we got to draw the sine wave. Okay. Now, that's the region. So what I always want you to do, I can't do it very nicely up here because I would need like a shading tool, which I don't really have on here. What I want you to do is lightly shade that region. There's a reason for that, because when we revolve it, we kind of have like a real part and a fake part. But this is the real part. Okay. All right, so let's revolve it and then take a look at what we get. So pull out your giant calipers. Everybody brought theirs, right, today? That's right. So let's see. I got that. I got that. I got that. Whoops. I got that. I I didn't make enough room. There. Perfect. Okay. Looks good to me. All right, so we'll open that puppy up right here. And this has got a little bit of a thingy here. Actually, this will be the solid one. Like that. So it actually turns into a nice little vase, doesn't it? Shape of a vase. Bless you. Now, from now on, for the disk method, okay, we're going to use the following. We're going to say the volume is equal to the integral from a to b of pi r squared dx. Pi r squared dx. So from now on, the volume formula, this is going to be the formula. The difference in it, that you might remember from Friday, is that Friday we used f of x. Okay? This is now the general form, and it handles when we revolve this thing about an axis that's not the x-axis. Okay? So, here's what I mean. With this, I want us to identify what the radius is at any given moment. Okay? What is the radius? So here's what I want you to do all the time on yours. I want you to draw in a couple of radii. Okay? To identify where is the radius coming from when we do the disk. It's pi r squared. And I should use the same r. So we're going to go uppercase R across the board. So they're all the radius. So do you see that the radius changes as we go from left to right? That forms the different size disks. That makes the solid. And we're accumulating all of those disks with the different radii. But what's the general formula for the radius? That's the question that we need to answer. Yes? Is it what? Sine. Can I say, is the radius always the sine of x? So on Friday we said we used the function. Today we're doing the general form. I'm going to check this out. Where's the first slice? Put this in the egg slicer. Where's the first slice? It's at 0, right? Isn't this where the radius is? How long is that radius? It's 2, right? So, in fact, I'm going to put one in here. The radius right here, that radius is equal to 2 to begin with. Where does that come from? Why is it 2? G of x minus h of x. Anybody else thinking that? That is correct. Because to find these from now on, if we move them off of the x-axis, we have to compute it. And in this case, you can either write it as g of x minus f of x, and that would be legal. Or, if you want to see the numbers, you can write it as 2 minus the sine of x. Same exact thing. Okay? Same thing. And what's fascinating about this is, look at here. Let's do the first one. The sine of, what's the sine of 0? 0. So the radius is 2. When we compute it. What do you think the radius is right here? 1. It's exactly 1. This is at pi over 2. What's the sine of pi over 2? 1. 2 minus 1 is 1. This formula tells you the radius at any given moment. Okay? That means that's what we're going to plug in right here. So once we have this, R is established, then we just have to identify what A is and what B is. So where do we start? We said we started at 0, and where do we end? 2 pi. So if you, on the AP exam, if you write this general formula, and then you tell them what R is, and then you tell them what A and B are, you can go straight to the answer. It's the same exact thing, but we're not going to do it as you saying this. The volume is equal to the integral from 0 to 2 pi of pi times 2 minus the sine of x squared dx. This and this, as long as we identify those, are exactly the same. All right, go get me an answer. What is the answer to this? Don't forget to square it, and don't forget to multiply by pi. Anybody else get that? Okay. Final answer. On these problems that are calculator based, you don't have to do any of the work. Just you do all the work on the calculator. And that's what we're doing in every one of these assignments. So in your homework, draw a picture, identify what R is, tell me where to start and stop, and then write the integral, and then give me an answer. Okay? The key is that this part right here is the top function, and this one is the bottom function, meaning top, bottom. Top, bottom. And it's the top minus the bottom of the real graph. That's the one that you shaded to begin with. So that's why it's important for you to shade. If you don't use that, you might think that this is the top function. But that's fake. It's not real. Okay? Because that's the part that we revolve. This region right here, that is the region that is the real area, because that's the key. It's the revolving the area. That's the real part that we're going to revolve. That's where we create the top and the bottom, top minus bottom, always. Make sense? Okay. Between the Friday's lesson and this lesson, you should be able to do all the problems that have to do with the disk method on the current page. Okay? Tomorrow we're going to take a look at the washer technique.